All right, so let's finish this unit, this lesson, by the last example on page 483. Okay, now this is an application questions. We're going to apply what we learn and then solve some algebraic questions. Okay, example number 3. Now we never see something like this before. The graph of g of x equal to the reciprocal of f of x is shown. What you see here is not the original graph, but is the reciprocal graph. Okay, this is the reciprocal graph. It's the g of x. Okay, it's the g of x, it's not the f of x. The maximum point of g of x is -3, 2. So here is -3, 2. Well, what does that tell me? The y-intercept is 1/5. Okay, the y-intercept is 1/5. So what does it tell me? Well, if g of x is the reciprocal of f of x, well, is also the reciprocal of g of x. Do you realize that? Because if you take the reciprocal of the reciprocal, it's become itself. So if you reciprocal the reciprocal, right? G of x is 1 over f of x, it just becomes itself. So the relationship between the reciprocal function is if you reciprocate it again, it becomes itself. So given f of x is a quadratic function, so they tell you it's a quadratic function, they want you to sketch it, and later on they want you to work out the equation. All right, let's do it. Now, this is the reciprocal function. This point, -3, 2, what does that become? Well, f of x is the reciprocal of g of x. So if you just take the reciprocal, you will get the original point, which is at 3, a -3, and then half. Okay, how many invariance points are there? Okay, same thing. Okay, 1 and -1 will be the invariance point. So it will be here, and it will be there. It will be the invariance point. And then let's graph one more point, which is the y-intercept. The y-intercept is 1 over 5 for g of x. So what's the y-intercept for the f of x? You take the reciprocal of 1 over 5, become 5, which is here. Okay, so therefore my quadratic function is a graph that go through 5, go through the invariance point, connect the vertex, go through here, and then it will be something like that. So that will be my f of x. So this is case number 5 in our summary, right? Number 6 is these 2 points will touch at 1, and then case number 7 is they don't touch at all. Okay, well, let's figure out the equation for this function. Well, how is that possible? Well, it's possible if we have the vertex, that is our P and Q. And to figure out A, we need one more point. Well, we have the invariance point. We can use that. We can also use this point. Let's use this point. Okay, 0, 5. Let's use this point. This will be our x and y. Okay. So let me put it here again. X and y, I can use 0 and 5. And then for my vertex, P and Q, I have -3 and half. So let's plug everything into this formula. Y equal to A, which is the unknown, x, which is 0, minus P, which is minus the double negative, square, and then plus half. Okay, so to solve, first you solve this part. Positive 3 squared is a 9. Don't combine the 9 with the half. The 9 go with the A. So 5 is 9A plus half. Okay, move the half to the other side. It's 4.5 over 9A. Well, 4.5 is 2 over 9. So find 9 over 2. Finally, divide by 9. A is half. Wonderful. Well, if you go back here, you can also figure out its half. How can I figure out its half? Well, look at this part here. It moved 1 unit across, and then it's only moved up by half, right? In a not regular shape, quadratic should be 1, 1, 2, 4, 3, 9. But here, this is at 0.5. This is the invariance point, 1 unit away. So 1, and then you move up by half. So how come it's not 1, 1 is 1 and then half? Because it has been compressed by half. So my final answer is y is equal to a x minus the vertex negative 3, so x plus 3 square plus half. So this will be my formula. If you type that in your graphic calculator f of x, you will see the answer we draw above. You type 1 over f of x in your graphic calculator, and then you will see the, the question that is given. Okay, so hopefully it ties everything together. All right, the relationship between any function and its reciprocal function, if it's reciprocal graph, and then you can use the knowledge of all of this, connecting everything together to even solve a problem like this, writing the equation. Okay, good luck everyone.